Hey guys, it's JP here. Welcome to the first episode of my new podcast. This will be a short one, so let's dive right into it. Today we'll be talking about the article by Stefan Schmidt over at the Amazing CTO blog with the title Just Use Postgres for Everything. Now, the article argues that you can just use Postgres for all your data needs because it is very powerful and scalable. And basically having less moving parts makes it faster and simpler to work with your application. I want to look at this article and discuss because there are things that I agree and disagree with, and I also have some things to add in as well. So stick around and let's dive right into it. Let's then look at how they propose to replace some common components in applications. The first one is Redis, which is an in-memory key value store, usually used for caching. Being in memory, it's blazing fast. In the article, they propose an alternative to this, which is unlogged tables. What then are unlogged tables that make them a good alternative to the blazing fast Redis? Well, as the name suggests, the data written to these tables are not logged to the write-ahead log before being written to the actual table. The while enables Postgres to avoid data loss on crash by replaying the events and applying them to the table. Skipping the while makes unlogged tables blazing fast but also volatile, but for a cache, it matters less. I agree with this proposal, but there will be definitely additional work on top of this to make it easier to work with, because working with a table structure will mean that you'll have to craft some SQL or use an ORM. So maybe it'll be better to have some sort of layer on top of that for writing and reading from key values in an unlogged table. Although another extra thing, if you use Elixir, you could just use ETS, which is built into the platform already. Now for the second one is for replacing message queues or just queues with Postgres. For Kafka, as a message queue, they propose using skip-lock, and for job queues, they propose using River. I agree with using River as it's just an implementation of a job queue on top of Postgres, but Kafka is a different story. So yeah, you can use Postgres with skip-lock as a message queue alternative, which basically acquires a lock on a row, and then when other workers pass through it, it will be ignored as long as the log is active. However, for other uses of Kafka, it's a different story. As a proper event stream service and doing parallel processing for different purposes using multiple consumer groups, skip-lock will not work because multiple consumer groups should be able to read a row even when other consumer groups are also reading it. So yeah, it depends on how you're using Kafka, but if you're trying to use it as a proper event streaming, just use Kafka instead of Postgres. Next one is using Postgres as a replacement for a data warehouse using Timescale. So Timescale is a times use database on top of Postgres. So let's actually look at that. Should be able to see that here, right? So this is Timescale. Now for me, it depends on what the data coming in looks like. If it's event, then yes, you can work with that. But if you're ingesting in batches, then it's a different story. Although I generally agree on using Postgres as the data warehouse, there are other options you can use when you're dealing with batches like Hydra. And for a lakehouse without the complexity of Spark, you can try PG Lakehouse. So PG Lakehouse or PG Quack. This uses PGXman. If you already have installed Hydra, you can just install this as well. These are a bit new, so probably just stick with Hydra or Timescale. It depends on what you actually need to implement in your data warehouse. For actual computations, right, Stefan suggests using PG Analytics, or as it functions as an in-memory OLAP that makes it more performant. It uses Data Fusion, which uses Arrow, so basically it's really in-memory. Apparently this is faster than Timescale, but it's slower than ClickHouse, just marginally faster than ClickHouse. But if I can just use Postgres for everything, then I definitely do that. I've had nightmares working with ClickHouse before. Nonetheless, PG Analytics like PG Lakehouse is relatively new, so I advise checking it out first to see if the features there work for you. At the time I checked them out, they still lacked some features I needed for some specific use cases, so I opted to use relatively more mature options. Now for JSON document storage, I agree with JSONB. Instead of things like Firestore, Dynamo, or DOG Mongo, it's because we mostly analyze using SQL. At least data analysts use SQL to analyze things. So if your JSON data is in Postgres, it's going to be easy to pull it out, create a new table or view, and then analyze it from there. We use JSONB here. It's a more efficient way to store JSON into Postgres. So this is actually pretty good as well. For cron, right, there's PG cron. It already is. If you already have a library in your application for that, then you can just use that, right? Otherwise, yeah, you can use PG cron as well, which just frees you up to not implement something like cron in your application. So instead of using cron, you can just use PG cron. And then for geospatial queries in Postgres, there's PostGIS. That's already sort of like an industry standard that a lot of people use. Usually when I hear people work with geospatial queries in Postgres, then we usually talk about PostGIS. I'm not sure what other options there are. So for full text search, Postgres has that built into it as well. But despite that, people still prefer Elasticsearch. But extensions like PGTRS and PG Search also makes Postgres capabilities even better and makes it a good alternative to Elasticsearch. Now Stefan also mentions creating JSON document from Postgres with no server-side code at all, but I'm not really sure when to use that, so I'll just skip over that. And it actually seems pretty convoluted as well to some degree. It might be easier to just build it in your like server-side code, really. It just depends on what you wanna do. But for me, I probably won't do this. And then moving on, if you need some comprehensive logs for possible like, government or compliance audits, then the article also mentions PG audit, but just take note that this might generate a ton of logs, so watch out for that. And the final thing mentioned here is automatically creating a GraphQL API from a Postgres database. And a suggestion for this is to use GraphGen. So that's what he mentions here, right? But the downside to this is it only supports Node and Go. But that's basically probably like 90% of the internet already. So, but if you need something else, right, there's Hasura, but it's outside of Postgres but built on top of Postgres. If you want an extension, you can use PG GraphQL, right? So that's the end of the article, but I do have a couple of other suggestions as well. So if you don't use GraphQL and want to use or generate a REST API directly on top of Postgres, then there's also there's also extensions for that, like Postgres. There's also Prest, but I think Postgres is the more Postgres. Let's spell that. Postgres. I think Postgres is the most popular one. Yep, this one. I think this is the more popular one. There are other alternatives, but that's the most popular one, I think. So you can use that. And then finally, for those working with AI, vector search, and RAG, there's PG Vector. There's also PG Vector Scale that builds on top of PG Vector. So there's this. It's some time scale as well. So it builds on top of PG Vector. And there's PG AI, which actually allows you to generate responses from AI using your own data as well as other optimizations directly in Postgres, right? So which is awesome. I might try this out. I might do a tutorial for this one of these days, but this is actually pretty interesting. And that is it for this episode. Postgres is a very powerful and scalable database with all these wonderful extensions. And although you can't build everything in Postgres, you can drastically reduce the amount of complexity in your application by replacing most of it with Postgres. I hope you learned a lot, and I will see you in the next episode. Peace.